This is the beginning of Unit 6, Week 1, Lecture 3. We're still talking about energy from electron transfer, and right now, so far you should now have come to understand that you can identify oxidation states, oxidation numbers for various atoms within in compounds, and from that you can tell whether or not there's electron transfer occurring across a chemical change, and then be able to label redox reactions and right half reactions and whatnot. Now we're ready to answer the question, like, how can you extract electrical energy from a redox reaction? And before we talk about this, I'd like to remind you that I wanted you to look at that Pogel voltaic cell activity so you can have a little experience with this before we start talking about it. And then this should just be a review of what you have just accomplished on your own by doing that activity, Pogel activity, that is. So in this type of electron transfer that we're talking about here, we're talking about a spontaneous electron transfer. And anytime you have a spontaneous electron transfer, that is a chemical change in which electrons are transferred and the chemical change itself is spontaneous. You bring the reactants together and the reaction goes. That's what we mean by spontaneous. In those cases, energy is going to be given off. And so, for example, in this particular reaction, we're going to look at this. This is a redox reaction, and energy is given off because it's spontaneous. So I want you to look at this picture, these two pictures, and we're going to write a reaction based on what's going on in the picture so we can understand what this idea of spontaneous electron transfer means. In this case, if you have a beaker and you have in the beaker a solution of copper 2 sulfate, a copper 2 sulfate solution. Copper 2 sulfate, as you know, is ionic, and so that means that if it's in solution, what's existing in the solution are copper ions and sulfate anions floating around, of course, right? Because it's aqueous. It's in solution. That means aqueous solution. And you stick into that solution a zinc rod. So this is the element zinc in this rod. Well, what happens shortly after you put that zinc rod in that copper 2 sulfate solution is the zinc rod starts to be eaten away, and you get there's like divots in the zinc rod, and then you get a precipitation of copper falling out onto the floor of the beaker. Okay, and so given these conditions, let's try to write a chemical reaction based on what's going on. So on this side, this is the reactants here that we've put together, and this is the result of the reaction. This is the products. Okay, so what we have, the reactants here, you've got zinc metal, that's one of your reactants, and then you have copper sulfate solution, that's another reactant right here. You're mixing them together, a chemical reaction is occurring, and the products, can you figure out what the products are just by reading these words? Well, precipitation of copper. Here we have copper ion in solution. Precipitate of copper indicates that the copper is now in the elemental form. And then the zinc metal is getting eaten away. Where is it going? It's not disappearing. It is going into solution from the zinc itself into zinc ion. It's dissolving away into solution. It's not going, you just can't see it because it's dissolved in solution. And we also have sulfates in that solution. We probably still have some copper ions and whatnot in the solution as well. But the important thing is the product then is zinc sulfate. Okay, the aqueous. Alrighty, so this is a spontaneous reaction. When I put these two reactants together, I'm going to have an oxidation reduction reaction where the zinc is going to be oxidized and the copper is going to be reduced. Okay, so we have the oxidation of copper. This is going to be oxidized, and the copper here, ion, is going to be reduced to copper metal. Alrighty, so when this reaction occurs, it's spontaneous. It's electron transfer because it's a redox reaction, and literally the electrons from this zinc are going to be transferred to the copper ion, and we end up with the product of copper metal. Okay, and so it's spontaneous, energy is given off. If I had a thermometer that I stuck down in here with these reactants, I would see that the temperature goes up a little bit, and a little bit of heat is given off. Heat given off. It's an exothermic reaction. Okay, So that's an example of an exothermic spontaneous electron transfer type reaction. Of course, it's not the first one we've seen. We see these types of electron transfer spontaneous reactions going on all around us. Anytime you burn a fossil fuel, you remember it's a redox reaction and heat is given off. It's exothermic.